Was that?
Boost mode?
No, they just.
See, that's why we didn't go down.
That's part of the reason.
I always have milk. Like, I swear to God, my family goes to like 2 to 3 gallons a week.
Yeah?
Yeah, we have
How many
like
kids you have?
2 gallons.
It's just my sister and I.
Well, you have 6 kids.
Yeah, so they go through it even worse than that.
6?
Yeah. Going on 15, man.
Huh?
As many as I can get. Give them to me.
Wait, how old are they?
Give me your kids, I'll take them. What?
I don't have
I'll raise them
kids
for you.
yet.
What's that?
Will I get an A if I give you my first child?
I'll give you my firstborn son.
No.
For a name.
No way.
But you won't need to compare, all right? That's too low for you, but you'll trade your kid for a grade. All right.
No, how old are your kids? I forgot.
Well, they've aged since
Last
I
time
talked about them last.
Well, that was in
I
January.
don't know.
You don't know?
Start at 13 and go down by 2. And that's approximately 13, 11, 9, 7, 5. Yeah, something like
Aww.
that. You gotta take out one of those numbers, but yeah.
What time do they go to bed?
How would I know?
Are they already asleep by the time you get home?
Sometimes not. Yeah, it just depends.
Oh.
They don't have school right now, so they think, it's okay to stay up. My wife's okay with that. They go to bed late, get up late. I don't really like it, but I'm there to crack down on them.
Oh, it's 6:04.
All right, I guess we should learn something. Besides,
I need a break though.
I need a break already. You do some play the
Back at 9 o'clock.
Yeah, but let's be no, 9 o'clock. That's too late. 8:55.
It's 6, chapter 6.
Let's try tomorrow. Let's try
I was thinking about my kids. I had 6 of them.
We just come back Monday. Yesterday was just too much. I need the rest of the week off.
You think the exam was okay soon? I thought it was a doable. I thought it was a doable.
That was pretty easy.
All right. So how do you want to approach this? I'm going to show you what to do or give you some definitions.
Definitions.
You want the definitions first? You really want them?
Definitions.
Definitions.
All right, fine.
After you go over, can we go over the online?
Yeah, sure.
Okay.
Yes, sir. Now we got to do 3 sections though, so if you start going too long, just let me know. You need to take a break.
We already said we need.
I mean, like, yeah, I already told you.
But I'm going to forget that you need it. So
We'll let you know.
So remind me about that
Set
need.
a reminder on your phone.
When it feels really nice.
Set an alarm.
Ah.
Shoot you an email anytime for a break.
All right, good. Good deal.
I can make it better with my phone.
So the whole goal of section 4.1 and 4.2 is to lead into 4.3 for the most part. And 4.1 and 4.2 are going to give us methods using derivatives to help us graph functions in 4.3. That's the main idea. So that's why 4.1, 2, and 3 we're going to try to blitz through those tonight. Right? So an important part of a graph, and even more so for 4.4 when we're doing optimization, is max and min values of functions. Okay? So an absolute maximum is if f of x is defined on an interval I. It's called I for fun. If f of x is defined on an interval I, and I mean these definitions are pretty straightforward. If f of c, right, when you put c into this function, that makes it greater than or equal to every other value this function could possibly put out, right? Any f of x that it is. Then f of c is an absolute maximum for the function. And c is where that maximum occurs. So there's the function value which is the maximum, and there is where maximum occurs. Where is always an x question. The max value is always the y question. Okay? Now, the definition for absolute min is so ridiculously similar to that. Oops. Absolute. I'm just going to use quotation marks and fill in easily to change. If f of x is defined in interval I and f of c is what? So all the way down to here, but fc is going to be what? So less than or equal to, right, every other function value possible for this thing. Then f of c is an what? It's an absolute min. And c is where? And c is where that absolute min occurs. Okay. That's pretty straightforward. These are also called global max and global min. Sometimes is the phrase used.
Wait, so what if f of c is equal to f of x? Would it be a min or a maximum? Or does that just
It would still be a min. There might be more than one location c where the function takes on the smallest value.
Okay.
That's all. Like, for example, you had some kind of picture like this. Let's say it was perfect, basically perfectly symmetric. So this height is the same as this height. But this is at A and this is at C. Then both A and C are locations of the absolute max.
Mm-hmm.
That's all.
Okay.
There could be more than one location for it. But the max is still only one value, right? It happens in two different places, but it's the same height, correct? Okay. So, all right. So now we're talking about local max. Local max and min. A little more restricted. Local max and min. If C is in an interval I, over which f of x is defined, so this definition will not be as obvious to you. I'll draw a picture and it'll become much clearer in a second. But right now, just the words will probably not be as clear to you how it indicates the local max as opposed to this, which is probably extremely clear. Right? So if C is in an interval I over which f of x is defined, and there and f of c is greater than or equal to f of x for all x in any open interval containing c on I, then that's called a local max. And f of c is a local max, and c is the location of the local max.